Hi guys, here is lesson 102. It is called Solving Quadratic Equations Using Square Roots. Sometimes quadratic equations do not have linear terms. So if you think about the standard form for quadratics, 0 equals ax squared plus bx plus c, sometimes you won't see this part of the equation, all right? Or especially this bx part right here. So if you see a quadratic in the form x squared equals a, how do you think you would solve for x? Well, the opposite of squaring something is to take the square root of it. So if we had x squared equals a, to solve for x, we would take the square root of both sides. The square root of x squared is x. The square root of a would be plus or minus whatever that number was. All right, so let's look at example 1. We have x squared equals 121. All right, how do we solve for x? Take the square root of both sides. So the square root of x squared is x. The square root of 121 is plus or minus 11. It's really important that you remember the plus or minus, all right? 11 times 11 is 121, but negative 11 times negative 11 is also 121. So please don't forget that plus or minus part. All right, let's look at x squared equals negative 400. How do we solve for x? Take the square root of both sides. The square root of x squared is x. What is the square root of a negative number? We can't do the square root of a negative number. A number times itself will never equal a negative number. So this would be no solution. You cannot take the square root of a negative number. All right, if the quadratic equation is in the form ax squared plus c equals 0, to solve that, we're going to first isolate the variable. Isolate means get the x all by itself. So let's look at example 3. 49 equals x squared minus 15. How do I get x by itself? I add 15 to both sides. And so I get x squared equals 64. All right. How do you undo a square? Take the square root of both sides. So x equals plus or minus, I should put that on the other side, plus or minus 8, right? You could rewrite it this way, x equals plus or minus 8. You could say x equals 8 comma negative 8. All of those mean the same thing. All right, how about number 4? 2x squared plus 5 equals 77. So I'm going to start by subtracting 5 from both sides. 2x squared equals 72. Divide by 2. X squared equals 36. Take the square root of both sides. X equals plus or minus 6, or 6 comma negative 6. All right, numbers that are not perfect squares have irrational roots. Irrational solutions can be expressed in square root form. You can leave your answer as plus or minus the square root of x. Your book suggests rounding to the thousandth place when giving an approximate answer. So if it asks you for the approximate answer or the approximate solution and use a calculator, let's say you got 1.77213. All right, we went around to the thousandths. Tens, hundredths, thousandths is right here. I'm going to look at the next number. It is a 1, right? So I don't have to round. I just rewrite the number, 1.772. What if I had 1.8456? Here's the thousandths place. This is greater than 5, so my answer rounded would be 1.846. So watch your rounding on those. All right. Number 5, 62 equals x squared. How do I undo a square? Take the square root. So what is the square root of 62? Can I simplify that? Let's prime factor it. 62 divided by 2 is 31. So the square root of 62 is actually already simplified, right? Because its only factors are 2 and 31, and I can't simplify 31 any further. All right, so what happens if I plug this into my calculator? Well, I would get 0.874007 equals x. I want to round to the thousandths. Tens, hundredths, thousandths is right here. My next number is a 0, so x would be 7.874. You can leave the square root of 62 That's totally fine. All right, how about the next one? Subtract 9 from both sides. 82 minus 9 is 73. 4x squared equals 73. Divide by 4. See why you want to use your calculator on this one? It's going to get ugly. 73 divided by 4 is 18.25. We're going to square root that. And so x would be, what is the square root of 18.25? Plus or minus 4.272. And hopefully you caught me on this last one over here. I forgot to do the plus or minus 7.874. All right, let's look at a word problem. Hannah covers a cube with exactly 1,536 inches squared of stickers. What is the side length of the largest cube that she can cover completely? So if you think about a cube, it's made up of squares, right? The side length is x. The area of one side would be x squared, but a cube has 6 sides, right? So the total surface area is 6 times x squared, 6 times the area of one side. They told us the surface area right here. So 1,536 equals 6x squared. How do I solve for x? Divide by 6. 1,536 divided by 6 is 2. Let's see, 6 goes into 33 5 times. 6 goes into 36 6 times. So 256 equals x squared. Take the square root of both sides. So x would be plus or minus 13. And this would be inches. So now we got to think about this in the context of the problem. Would it make sense? It's not 13. Sorry, guys. It is 16. 16 inches. Would it make sense to have a negative side length for a square? No. So my answer for this one would be positive 16 inches. All right, there's more practice problems in lesson practice on page 687. If you want to check those out, please let me know if you have any questions or need any help. Talk to you later.